Hey everyone, welcome. This is Advanced VPC Design and New Capabilities for Amazon VPC. I'm Matt Lewis. I'm a Principal Developer Advocate over here at AWS, and we've got a whole bunch of stuff to talk to you folks about today. This session is actually, I think this will be the 4th year running at reInvent, and the idea is we'll talk about Advanced VPC Design, so all of the things that go into building your VPC design in AWS, but then all of the that we've released over the last 12 months. So that said, what we'll actually be doing is taking a little step back in time to November 2019 and talking about the way things were 12 months ago. We've got the logo there. I thought that was an interesting one to throw in here in this session. That was actually from 2006, I think. All right, so an Amazon VPC, and when we talk about Amazon VPC networking, we're generally talking about deploying things like EC2 and VPC, or Amazon Virtual Private Cloud. And so what that looks like is we've got an AWS region, we've got our VPC, we've then got a CIDR address range. We can expand that range or add ranges to a VPC. We've got IPv6, but then essentially we can build inside an AWS region, which is constituted of availability zones. And so when we deploy in the VPC, we're deploying subnets, and then we deploy our instances inside those subnets. And this is generally what a VPC architecture would look like in its purest form. And so then if we look at the other services that you'll be interacting with, some of those services are public, like S3 and DynamoDB, that sit outside of the VPC. And so we might want to connect to the public internet, or we might want to connect to S3 or DynamoDB. And to initiate those types of connections, we have a route table, which will determine what the VPC can communicate with. So here we've got 2 route tables, one for our public subnet and one for our private subnet. And so then we can attach an internet gateway or an IGW to the VPC. We can create a default route, and we can then route things to the public realm of AWS and the public internet by assigning a public IP to our instance A, for example. We could also use a NAT instance if you wanted to, or hopefully you'd be using NAT Gateway now, which is a largely scalable NAT service or network address translation service. And as we kind of go along here, you'll see all of these components build out on the diagram here. And so if we wanted to connect to S3 or DynamoDB publicly, we'd go via the internet gateway. But in recent times, we've heard a lot of feedback from customers to say they'd like to connect to services privately from the VPC. So Gateway Endpoints was the first service that we released for private connectivity to S3 and DynamoDB. And we could use that if we wanted to by setting a prefix list towards a gateway endpoint. We can then also privately talk to our on-premises using a VGW with VPN and Direct Connect. And so the VGW is going to be a gateway just like the IGW that connects to your on-premises though. We can also do VPC peering. So if we've got a whole bunch of VPCs you want to connect to, you can do intra-region peering, so within a region, or inter-region peering. And then we also realized back in about 2017, 2018, that customers just weren't building 1 or 2 or 3 VPCs. They were building hundreds of VPCs or thousands of VPCs. So we built this service called Transit Gateway, and that allows you to connect to up to 5,000 VPCs within a region. Now, Transit Gateway has since become a centralized hub for network connectivity within a region, and so we can now connect to other transit gateways through VPC peering. We can connect VPN connections to on-premises and direct connect connections via a transit virtual interface. So Transit Gateway is really that central hub for intra-region connectivity, inter-region connectivity, and then hybrid connectivity to your on-premises. Now, if we keep building out our architecture here, we've got VPC flow logs for things like visibility into the traffic that's traversing your VPC. We've got Privatelink, which allows you to front a service in another VPC with a endpoint or endpoints that operate inside your VPC. And we've actually used Privatelink to front a whole bunch of different services. We'll talk about Privatelink. And then we've got Global Accelerator, which sits outside of the VPC, but allows you to have a fully featured Anycast-like service that can front your regional deployments. Now, I need to make a bit of room here, so we'll remove the route tables. But we also have traffic mirroring, which allows you to mirror traffic from an instance to a monitoring instance. Could even be, it could be a EC2 instance, or perhaps even a network load balancer. We also have ingress routing or gateway route tables at the IGW that allows you to send traffic to a particular destination as it comes into the IGW. And ingress routing or gateway route tables is an extremely important service that we'll talk about, or feature we'll talk about in relation to another feature that's coming up that we just launched. We also have Client VPN, where you can use a client to connect to your AWS deployment. And Client VPN has been immensely popular in the last 12 months or so. Lots of customers using Client VPN to connect to their AWS deployment. And lastly, here in this architecture, we've got AWS Outposts. And Outpost is where we're extending the VPC that you see here to your on-premises and to hardware that's operating within your premises. So amazing that you can have AWS right inside your data center or in your co-location facility and extend that VPC all the way down to that hardware. And it's a managed service that we operate and offer to you folks, where you can deploy EC2 and EKS and RDS, etc., on the Outpost. All right, so that said, now we've taken a look at what all of those services look like and how they come together into an overall architecture. We'll start talking about each new service or features of new services individually. So we'll start with Privatelink. And what I've actually done here, because we'll be rolling pretty quickly through these, just in the interest of time, as this is only a 30-minute session, I've put some QR codes in here. Feel free to grab your smartphone, take a photo. It should take you to a link directly to more information about each of those services. So all of those QR codes will be updated as we go through and talk about all of these services. So let's start with Privatelink. And particularly, we'll start with interface VPC endpoints. So when we look at an interface endpoint for VPC, we've got a whole bunch of services that we've built interface endpoint capability to communicate directly and privately with your VPCs from those services. And so we'll drop a couple of Elastic Network interfaces inside the Amazon VPC here for example, the Amazon API Gateway. And you'll notice that we don't need any routes because we're actually using Elastic Network interfaces from within the VPC. So it's all part of what we call the local route, or the 10.1.0.0/16. And so before, and whenever I say before, I mean before reInvent last year, or before this last 12-month period that we've gone through, we had 41 services that supported Privatelink. And so now, if you look into the interface endpoint console, we actually support 92 services. And so you see all of the services that we have listed here, plus many more. And we can now also do fine-grained IAM policies to interface endpoint creation with AWS services. So let's have a really quick look here at creating an endpoint. We go to our VPC, we go over to our endpoints, we create an endpoint, and then you'll notice here, these are where all of the services that you can create interface endpoints for. And so we have, this is showing one of 50 of 93. So if you want to keep an eye on that in the console as we go along in the next 12 months, there'll be a bunch more services that we add to that, I'm sure. All right, so let's move along to VPC endpoint services. And again, I generally update the QR code in the top right-hand corner for each one of those screens as well. So interface endpoint services are where we've got a customer VPC, we've got a service provider VPC, we've then got Privatelink, we've got an NLB, and we can do things like tagging an endpoint. Endpoints are reachable over intra or inter-region VPC peering, and you've got this service provider VPC where your service is essentially running behind an NLB, and you can offer that service to other VPCs. And so over the last 12 months, we've now got, as of a few days ago, we've now got 450 plus ISV and SaaS partner solutions that you can use with Privatelink. So what that means is we've got over 450 partners that have built Privatelink services that you can subscribe to. We also now have private DNS names for internal or third-party services and fine-grained IAM permissions as well for endpoint services. And I've thrown a couple of QR codes in the top corner there if you want to learn more about those features. All right, let's move along here to monitoring and visibility. And the two things I think about when I think about AWS and monitoring and visibility, it's really VPC flow logs and VPC traffic mirroring. And so if we start with flow logs Flow logs is basically where we have three different sources here, the interface, the subnet, or the VPC, and we send metadata of traffic to VPC flow logs, and they can be sent to either Amazon CloudWatch or Amazon S3. And if we look at a flow log or the contents of a flow log, we have things like the flow logs version, the account ID, the source and destination, the protocol, the packets, the bytes, the start and end, because this is for a particular time period, the action, and then the log status. So this is what a flow log generally looks like. And so now we actually have faster flow logs, so up to 1 minute aggregation intervals. So flow logs are going to operate a lot faster than they did before. We also have tagging support for VPC flow logs, so you'll get tagging support for more granular IAM and cost allocation and that sort of thing. And we also have enriched flow logs, and this is going to open up availability zone, subnet, instance ID, TCP flags, packet source address, packet destination address, so a bunch more different fields in flow logs themselves. Okay, let's move on to traffic mirroring. And again, I am moving pretty quickly here. Some of these are incremental feature updates to these services that you already know and love and use today. So we'll move pretty quickly through, though. I've got some new services I want to really dive deep on. So when we think about traffic mirroring, we've got an EC2 instance, and we create a traffic mirroring session, which then will send packets destined to and from that instance to another instance, which is a monitoring instance. And that monitoring instance is essentially where you can build your own traffic analyzer. You can have open source, you can use our open source traffic analysis, or you can use our traffic mirroring partners. And so what we've done now with traffic mirroring is we can have our CloudWatch metrics for monitored or mirrored or dropped packets sent to CloudWatch, so you get a bit more of an idea for what's actually happening for those traffic mirrored sessions. So we have things like network mirror in, network mirror out, packets in and out, and then also skip mirror in, which I'll talk about. And so these new CloudWatch metrics for traffic mirroring essentially allow you to see the number of bytes sent and received for a network interface that's being mirrored, and the packets in and out for a network interface. But lastly here, the network skip bytes. So the number of bytes received that meet the traffic mirroring filter but didn't get mirrored because of production traffic taking priority. So what we'll actually do if an interface is overrun, we will prioritize production traffic over mirrored traffic. So this CloudWatch metric will give you that ability to see into that. And a quick link in the top right-hand corner if you're interested in traffic mirroring CloudWatch metrics. Okay, the next one here is pretty exciting. This one has been on our list for a long time. Internally, we've been thinking about how to build this. And I spent about 5 years on the partner team trying to help our partners integrate more closely into AWS to help you users and customers build things like firewalls and appliances and other things in AWS. So Gateway Load Balancer launching was extremely exciting for me. And so what we'll do here, we'll talk about a few architectures before Gateway Load Balancer. And so here we've got a VPC with an active and passive firewall. We've got some instances and we've got an internet gateway. What we can do here is use route tables to send traffic to the active firewall, and essentially now the active firewall is operating in line for any traffic going to and from those instances. The downside being routes are only one destination, or you can only have one destination for a route inside a VPC route table. And so to fail over, you do need to do a route shift from one firewall to another, and that constitutes having a monitoring instance and an API call, etc. And so what customers started doing, and this was actually an ingenious topology that we were told about 5 or 6 years ago, where folks would go in and create a VGW and attach it to a VPC, and then use IPsec and BGP to have IPsec sessions or IPsec connections to an active and passive firewall. And so what you're doing now is you're using BGP or Border Gateway Protocol to fail over from one firewall to another in case that active firewall fails. And so you don't need to have a monitoring instance and do an API call or anything like that. And what you've done now as well is you've got a centralized VPC that essentially has a bunch of firewalls in it, and so it's almost like an edge VPC. And so here we've got our routes, we've got our default route for our VGW pointing towards the active firewall here. Now, then we launched Transit Gateway, and things got very interesting for the appliance vendors. So what we've got here is we've got our VPCs on the left-hand side, we've got our Transit Gateway, and then we've got our TGW attachments for those VPCs. On the right-hand side, we've got our inspection VPC. And the inspection VPC has our firewalls, where we maybe have certain firewalls deployed in each availability zone, and they're connected to our Transit Gateway using VPN. The difference between a VGW and a TGW VPN, though, is the VGW doesn't support ECMP, or equal cost multipath. In this case, the Transit Gateway does support equal cost multipath, and we can load balance across these firewalls if we'd like. And so what we've got in this scenario is a bunch of firewalls in an inspection VPC that we can now potentially auto-scale. And you've got a scalable inspection VPC connected to your Transit Gateway. This is a little bit complex if you look at all of the rules that you can employ, but it does give you a lot of control over where your traffic's going. The last topology before Gateway Load Balancer I've got here is a famous ELB sandwich. And so this was a term that was coined probably also about 5 years ago, where essentially we've got a set of firewalls or appliances that are sitting in between a set of elastic load balancers. And so we've got our routing configured, and what happens here is traffic comes in the internet gateway, goes to the firewalls, hits the elastic load balancer, and then hits our application or web instances, for example. Actually sandwiching firewalls between two elastic load balancers. Okay, so let's talk about Gateway Load Balancer, and now after we've deployed Gateway Load Balancer. What we've got here is a source and a destination in a VPC, appliance fleet in another VPC, and then we've got our Gateway Load Balancer endpoint, which is a new component in AWS that you can use. So it's a new type of next hop that you can configure for your routing, and instead of the traffic going directly to that instance, it's going to hit the Gateway Load Balancer endpoint. Gateway Load Balancer, which is a layer 3 plus layer 4 load balancer sitting inside the other VPC. And we're essentially sending traffic from the Gateway Load Balancer endpoint down to the Gateway Load Balancer in the other VPC. Very similar to the way that works, and we are in fact also using what we call hyperplane for the Gateway Load Balancer, which is a technology we use in our NLB, and we use it in Privatelink and Transit Gateway, so it gives immense scale when it comes to these services. And so a couple of different benefits here. We can provide horizontal scaling. You can build that with no problems, which lends to fault tolerance, and the Gateway Load Balancer is also transparent to network traffic, as we don't change the source and destination of the traffic because we're encapsulating it in what we call Geneve protocol, or in Geneve encapsulation. So application firewalls need to decapsulate that and then do things with the packets that are inside that are preserved. Now we basically have a separate domain here. We've got a consumer VPC and our provider VPC again, and essentially we're offering a appliance you to be able to build these appliances as a service to many other VPCs. Okay, so if we look at a few different topologies here we've got a Gateway Load Balancer and a Gateway Endpoint, and I just want to show the traffic flow here as it comes into the Internet Gateway, Gateway Load Balancer, and get Gateway Endpoint and go over to the Gateway Load Balancer. It'll hit our appliances, go back to the Gateway Load Balancer, and towards the instances. Now, return traffic, because we've got our routing configured, goes the same path. So the firewall instances, for example, will see both directions. It's in line for both directions, so super useful there. Now, this does lend itself to a few different topologies where we could have multiple VPCs connected to a Gateway Load Balancer, and each VPC or Gateway Load Balancer endpoint will be encapsulated in a different encapsulation, but identifiably different, so that the firewalls know where that traffic is coming from. And we could build a centralized inspection VPC using Transit Gateway, in this case with the Transit Gateway attached to an appliance or security VPC that has the Gateway Load Balancer, and in this case we've actually got a centralized edge VPC with a NAT gateway. And so this could be for north-south traffic, but we could also build another VPC for east-west traffic between our VPCs. And in this case, we could have the north-south and east-west in one VPC if we want, or we can separate them if we'd like, or we could put the NAT gateway in the appliance or security VPC. So we collapse the edge VPC and the security VPC. So there's a lot of different options when you're deploying this with Transit Gateway as well. So we have a whole bunch of partners that worked with Gateway Load Balancer at launch. We've got our advanced security partners, we've got our analytics partners, our orchestration partners to help you deploy this kind of stuff, and folks like E+, our system integration partners to help you build these kinds of topologies. Some key takeaways on Gateway Load Balancer: we're reducing complexity, giving you elastic scale for your appliances, improving appliance availability, and we're supported by leading appliance vendors as well. That leads us to the next service that we just released. This one is super new, AWS Network Firewall, and we've got a QR code there as well. So Network Firewall is essentially a native firewall service that we've built in AWS. And this is going to give you control over the visibility across layer 3 to 7 of the OSI model and basically allow you to inspect your VPC traffic. Now, it does provide stateful and stateless rules, IP port protocol, and FQDN, or fully qualified domain name based filtering, which is a huge feature, regular expression matching, and then allow drop alerts, etc. And you can also do logging. What I'm interested in, though, is, we can do, it's fully managed, flexible deployments, fine-grained controls, and we do have partners integrating with Network Firewall. But what I'm actually interested in here is the network architecture. So if we've got a VPC here, just like a gateway load balancer, we've got our network firewall deployed inside the VPC, we've got our internet gateway, and now we're using routing to send traffic to and from the network firewall. And as I mentioned earlier, the ingress routing or gateway route table for the IGW is super important here to get traffic as it comes into the VPC and send it towards the network firewall. But this is generally what a topology would look like. And so we can build the network firewall with Transit Gateway in this case. So now we've got a centralized VPC with a network firewall. And essentially this is going to allow you to have that centralized VPC with a managed running inside that security VPC. All right, we move on to AWS VPN here. We start with Client VPN. We've only got a quick update for Client VPN. So basically, Client VPN, as I said, immensely popular in recent times. We've had a lot of customers that are really delighted by the fact that we have Client VPN as basically a managed service here you can attach to a VPC. We've got a user with OpenVPN, a TLS-based tunnel, an attachment to a VPC, and that VPC can then communicate to other VPCs. And so what we've done I think it was a few months ago, we released the ability to we released a new desktop client for Mac OS and Windows. So we now have an AWS-based client for Client VPN. But essentially what you see here is what a Client VPN architecture would look like. All right, let's move on to site-to-site VPN. I've got a few updates here. Now, site-to-site VPN has been around for a long time. And I believe when we first launched Amazon VPC, you could only use a VGW, so you could basically extend from your on-premises data center. And I think the IGW came a little bit later. Maybe someone can call me out on that one, but basically the virtual private gateway is the ability to connect to your on-premises via VPN or DX. Now, when we use VPN, we now call it site-to-site VPN. It used to be called hardware or AWS managed VPN. But essentially, we've got our VGW, we've got our customer gateway, and we've got IPsec tunnels between the two. And what we've recently done for site-to-site VPN is we've added a whole bunch of additional encryption options. Definitely worth scanning this one to check out more detail on the encryption options. This is something that a lot of customers were asking for a long time, being able to support things like SHA-2, 384, etc. So that was a great win for us. Also, tunnel initiator mode. The VGW would never initiate tunnels, but with initiator mode, it does. And so what you can do now is have the tunnel initiated from AWS down towards your on-premises. I've even seen some crafty solution architects put together a topology where you can connect two VGWs via IPsec together. Now, the real thing you want to do is probably Transit Gateway or use VPC peering, but it is possible with dynamic routing to connect two VGWs together. I probably wouldn't recommend it though, but as an interesting use case, that was definitely something that surprised me. And lastly here, if you are using the Transit Gateway for site-to-site VPN, which you can do, We also have IPv4 or IPv6 as traffic inside the tunnel. So our outside tunnel does need to be v4 still, but inside that tunnel you can use v6 as well, or v4. So you get a bit of a choice there. I'd like to actually see a lot more v6 uptake in AWS, and I think that's the real direction that successful customers will be taking in the future. So we'll see what happens next year with v6. And again, a quick QR code there for you folks. All right, so let's now talk about Transit Gateway. We've moved from VPN into Transit Gateway, so that was a nice little segue. Transit Gateway has a few updates here, where before, the Transit Gateway is essentially the ability to connect to many VPCs, up to 5,000. Now, if you're a customer that's using 5,000 VPCs, you'd probably reach out to me and we should probably have a chat. I have seen customers use upwards of about 1,000 or more VPCs though, so we do have customers that do that. Now, the Transit Gateway is also used for on-premises connectivity with things like VPN, Transit Gateway, and also the Transit VPC architecture that we talked about earlier. We did also deploy cross-region peering last year, and that gives you the ability to peer transit gateways across regions. And at launch, that was US only. It is a new attachment type, and it does use the encrypted VPC peering capability. With VPC cross-region peering, we essentially have encryption that operates between the regions, and Transit Gateway uses that as well. We don't have peering between transit gateways in the same region, though. And so if we look at what a topology looks like here, essentially if we have many regions, we do suggest a full mesh of peering. So every transit gateway can talk to everyone else. And that's going to prevent you from tromboning through regions and having poor latency and that sort of thing. We do also ask that you configure unique ASNs for transit gateways. And before reInvent, we did support only a couple of regions. So our US regions, our EU, Ireland region, and Asia Pacific in Mumbai. We now have cloud attachment level metrics available for CloudWatch, and we're also supported in many, many more regions. So Transit Gateway peering, you can peer with transit gateways across all of the regions you see here on the slide. We've also launched what's called Route Analyzer, and I'll cover this pretty quickly here, but essentially Route Analyzer gives you the ability to verify the transit gateway route table configuration so that you know that it's going to work as expected. So you can basically validate your routes and make sure they're there where they should be. And if you would like, you can also diagnose route-related issues, because we do realize that with routing and a transit gateway, you can have up to 10,000 routes. So 5,000 VPCs per transit gateway and 10,000 routes. And that can get complex when you've got a whole bunch of VPCs that you want to connect to, and now we have peering. So Route Analyzer helps simplify that a little bit and give you a bit more visibility into what that looks like. A quick QR code there for you folks too. I also have a quick screenshot here that's been heavily redacted because of all the account IDs and transit gateway IDs, but this does give you a quick high-level view on what Route Analyzer looks like within the console, but you can jump in and check it out in your console as well. It's available for everyone. Lastly here with Transit Gateway, with Gateway Load Balancer, we needed the ability to have an appliance mode. Now what happens here is we've got a transit gateway and we've got some appliances. And so traffic comes in from our instance, heads towards an appliance, and if the destination is in another availability zone, what's going to happen is Transit Gateway will receive the response and try and keep that packet in the same AZ. Transit Gateway tries not to send traffic to other availability zones. But in this case, because the sources come from AZ or availability zone 2, traffic's going to be going up to the other appliance. And now this is actually a problem for things like flow symmetry, where appliances really need that flow symmetry across appliances to be able to do their job properly. If a firewall sees a session come in and not go out again, or go out but not come in again, that can cause problems for the way the firewall or appliance is going to operate. So appliance mode essentially lets us have the traffic remain in the original VPC, the original availability zone. So traffic will get sent back up from availability zone 2 to the original appliance that the traffic had sourced from. So this is going to make sure all of your appliances are happy. So flow symmetry in this case has been restored because we turned on appliance mode. Okay, this leads me to one of my last updates, and this is actually a huge one. It seems so simple, but just the number we're seeing here, so 400 gigabits per second networking for our P4D instances. Quick QR code if you'd like to learn more about P4D instances. But what we're doing with this is, and this is a cloud first. I haven't heard of 400 gigabits networking anywhere else. And I used to work for a very large service provider that operated an internet backbone for a country. And I think we maxed out at about 160 gigabits per second. So now you can spin up an instance inside AWS that's more than that. There's 400 gigabits per second. So the way that basically looks is we've got a P4D instance, and then we have 4 100 gig ENIs. And so you can connect in an ultra cluster between those P4D instances across those 4 100 gig interfaces. Now, the last thing I'll just point out here is we're essentially using multi-NIC. So each instance has multiple networks. I'm excited to see where this multi-NIC piece is going to take us, but 400 gigabits networking is amazing. And you can spin up a P4D 400 gigabits instance if you like today as well. All right, so just wrapping up here, we've got a couple of honorable mentions. Bring your own 6 was released, so if you want to bring your own IP range to AWS, you can now bring an IPv6 range. IPv6 for network load balancer was also released, worth checking out if you're interested in load balancing with IPv6. And again, I mentioned it earlier, v6 is super important. And then lastly, Amazon VPC prefix list. So you can create a prefix list to help simplify your configuration of your security groups and route tables. Worth checking out too to help with some of that simplicity. So I do have a couple of related sessions. Feel free to take a screenshot of this. I just handpicked a couple of sessions that I thought were worth checking out from the catalog. And these are all networking-based sessions. There's an Outpost session in there as well if you want to learn about Outpost networking. And so on behalf of all of the products and services that we've launched this year, I just want to thank you folks for tuning in. And I hope this has been as exciting for you folks as it was for me. I'm super excited for seeing what's going to happen next year. And I can't wait to get into the console and start playing around with these things like our 400 gigabits networking or gateway load balancer or AWS Network Firewall. So super exciting stuff. If you'd like to reach out, my social media is there. And please don't forget to complete the survey after the session. I really do appreciate it. Thank you very much.